Hello everyone. So in this video we are going to continue with ER diagrams. Okay. So here in this particular slide I'm just illustrating this concept of self relations. Just to show you that such things are also possible. So for example, if you have an entity on movies and then there is a relationship of an entity with movie with itself, right? So something like sequel of. So so you can draw something like this, that a movie is related to itself through the relation of sequel of, right? And then you can just for our interpretation you can write these labels as sequel and original, right? And now when you sort of convert this particular relationship set into a table, you're going to have two copies of the movie primary key. Now to disambiguate, you will have to rename them as primary key of the original and primary key of the sequel, right? So here one thing to note is that I'm saying that movies, the sequel of relation, it's a many to one relationship with itself, right? So the reason being is that in the application domain, from where this has been picked up, the concept is that there will be just one original movie and several sequels to it, something like that. But so don't take this too seriously. It all depends on the interpretation and the business logic that you are required to uh, model, right? So the key thing is that self relationships are possible, right? And here's just an example of that. Okay, so in the next slide over here, what I have done is that I have created a small example for you to work out, right? So here the application is of bank, and you have some concepts such as there is a customer, and then a customer has attributes such as name, address, phone number, pan number, and so on. And then accounts have types, balances, right? And people will hold accounts. You can have a joint account, right? In case of a joint account, an account is held by multiple customers, right? So you have concepts like this, and then you need to draw an ER diagram. So I would want you to try this by yourself first, and then get back to me if you have doubts. Okay, so I have put in some pointers over here to get you started, but I think I would like you to try this by yourself as an exercise. Okay, on. Okay, so now I would like to take some time to talk about multi-way relations, right? So in a multi-way relation, uh, basically the relationship uh, involves entities from more than two entity sets, right? So over here I'm illustrating this concept of contract. So you have entity uh, sets on stars, movies, right, and studios, right? And then the concept that we are trying to capture here is that when a star signs up for a particular movie, a contract is written down, and that contract is held by an studio, right? So therefore this relationship of contracts is a multi-way relationship between the entity sets, stars, movies, and studios, right? So that's the concept here. And I would like to take some time and focus on this bold arrow which I am pointing it to studios. So when if you had just a binary relation, that just two entities and then a bold arrow like this, I would have said that we have an many to one relationship from here to here, right? So that was the case in binary relationship. But now in this relationship you have three entity sets, and then I have an bold arrow over here. So the way to interpret this is that if I pick a pair of star and a movie name, a star name and a movie name, I can uniquely identify the studio in which the contract is sitting, right? So that means that for a unique pair of stars and movies, there will always be a unique value of studios. So in other words, I'll say that contracts is a many to one relationship from the pair stars and movies towards studios, right? So it's a many to one relationship from stars and movies to studios, given that we have an bold arrow entering studios, right? So now if I had an bold arrow entering here also, then it means that it is a many to one relationship from stars to these things, right? uh, I am guessing that most of the diagrams that you're going to draw in this course will probably just have a situation like this and not too much like this. But we'll see if anything comes. Uh, we'll deal them case by cases, right? So now if you were to convert this contracts relation into a table, you will have the primary key from star, movie and studios. Each tuple will have the primary key from stars, movies and studios, right? And of course, all these three will be having an foreign key constraint, and the primary key for this contracts table would be stars and movies itself, because given a pair of stars entity and a movies entity, I can uniquely identify studios. So your primary key need not include studios also, right? Okay. We'll keep coming back to this multi-way relations again and again. So for now, let's move forward. Okay. Sometimes, as I said before, your relations can have attributes. So, for example, in this case, this contracts relation has salary as an attribute, right? So now, when you convert this into a table, you'll take primary key from here, here, and then just an attribute called as salary, right? So all those four will be the columns of the contracts relation, right? And as I said before, primary key of this will continue to be the combination of the primary key from here and here, right? Because it's a many to one relationship from movies and stars to studios, right? Okay, forward. Okay, sometimes your attributes can also be entities. So this is a slightly different kind. So here contracts is a relationship between movies, stars, studios and salary, right? And then I have a bold arrow entering here and here both, right? The way to interpret this is that given a star and a movie, I can uniquely determine the studio where the contract is sitting and the salary where the salary corresponding to this contract, right? So now, when do you want to make salary as an entity but not as an attribute, right? So you have to be careful as to not introduce unnecessary entities into your diagram, right? So typically, if you ask my advice, you put salaries as an entity or date as an entity when you have a fixed notion. So for example, if you were so if you have to maintain a calendar in your application, right? So then the date becomes an entity, because in a calendar, given a calendar of, let's say, 2020, right? So those dates are fixed. And now let's say if you're trying to book railway reservation tickets or something like that, right? So date of journey will always be an attribute, but that comes from a calendar. And that is one example. Another, even a much more closer example to this case, is that if you have a structure in your salary. So for example, for if all the employees in a company uh, or different projects or something, if the salary components are fixed, then it makes sense to make salary as an entity, right? So for example, let's say that let's say the studios was not there, you just had people and then you had projects, right? And then the salaries uh, which can be drawn from a project, they fall in an hierarchy. They fall in a fixed scale, right? Either you are grade 1, grade 2, grade 3, grade 4 and all that. If you are falling in grade 1 employee, then your salary is fixed, right? So now if a person is drawing salaries from multiple project, then this contract, each contract will tell us the salary which the particular project investigator can draw from the project, right? So then what happens is that given that all my salaries, they are fixed in a certain grade 1, grade 2, grade 3, salary should no longer be an attribute, rather than salary should be an entity set by itself. So now when you pick a project investigator and you pick a project, you can uniquely identify that for this particular contract, this PI is going to get the salary of an grade 10 employee, right? Now, what is the salary of a grade 10 employee? That will come from this entity, right? There is another advantage if you put things like salaries uh, as an entity. Then what happens is that whenever salaries are revised, you don't have to go back and change your contract. So for example, in government of India, the JRF salaries, junior research fellowship salaries, right? A student is employed in a project, and there can be a notice from the government saying that from this date onwards the JRF salary is increased, right? So then in that case, you don't have to go and change the contract, just change the table or the values of the salaries in the table, and these contracts will keep pointing to the appropriate pay cell, right? So that is advantage of creating salaries as an entity. Okay, I think I'll move forward for now. When you start doing your course project, I think this thing will come up again, because in the course project you are expected to implement an railway reservation system. There, you will face this dilemma of whether to create date as an attribute or as an entity, right? I'm looking forward to having a lot of live sessions during the course project time, right? Because these doubts, I would, rather than me telling you, you should automatically try it once, and then when you get into trouble, then we have a discussion and move forward. That's the best way of doing it. Okay, going forward, let's see what. Yeah. Okay, so next couple of slides, the here what we are talking is that given a multi-way relation, something like this, right? Can I convert a multi-way relation into an binary relation, right? And there are ways of doing it. So, for example, over here, I picked it from your Koth textbook. So, if you have a multi-way relation like this, you can convert it into you take this relation away, you create an entity, and then you create relationship with all the participating ones. This technique works sometimes, but it does not work always, right? So there are a few special cases where this kind of an conversion does not work out, and let's see what those are. So the first case is this this kind of an constraint where we say that let's say there are three entity sets which are involved in a relationship R, and the entities are A, B, and C, and there is a multi-way relation R among these three entity sets, right? And we have a constraint which says that the relation from a pair AB, if you give me an unique pair AB, I can determine the entity in the entity set C. So in other words, I have a multi-way relation from the pair AB to C. right? Very, very similar to the ones which you have seen before, right? Over here, you had movie stars, and then the movies and stars together are, many to one relationship to studios, right? So if you have something like this, then that constraint cannot be broken down into an collection of binary relations. So we'll see more of this when we study uh, normalization theory and functional dependency theory. But you can take it from me for now that whenever you have a constraint like this, that it's a multi-way relation from the pair AB to C, then this cannot be translated into an equivalent relationship among its binary relation counterparts. So that is one disadvantage. And the second one is that when you are creating an entity like this, right? So this entity, you need to define some kind of an primary key for this. Remember that, relations, when they get converted into tables, they will pick primary keys from the participating entity. But when you have a box here itself, then you need to identify what is the identity over here, what is the primary key over here. That may not be always possible, so there are workarounds for it. uh, Towards the later part, I'll cover something called as weak entity types. So there you get some partial solution. But uh, the moral of the story is that don't be afraid of multi-way relations. If your business logic dictates a multi-way relation, go for it. If your business logic dictates and weak entity, go for it. Don't forcibly convert multi-way relations to binary relations. They don't always work out properly. Okay, next slide. Okay, so there is this concept of referential integrity in ER diagrams. Okay, you might remember our concept of foreign key, right? So uh, the textbook, the Ullman textbook, they have their own scheme for putting this, right? I'll just take 2 minutes to explain this. Okay, so first let's see the left portion over here. I say that movie is owned by studio, and I have put a line like this, right? So if the line was not like this, then I would have put an bold arrow, something like this, and I would have put a bold arrow over here, and then I would have said that movies, owns is a many to one relationship from movies to studios. And then when I converted this owns relationship into a table, I would have taken primary keys from here and here, and then I would have uh, put relevant foreign keys, right? So that's typically how we do things, right? But if you want to be very specific in your in your drawings, then the ER diagrams gives you this curved arrow symbol, right? So this curved arrow symbol means that for this guy, owns is a many to one relationship from movies to studio. So that part still says as it is, and the second part says that uh, so any the second part says that uh, f related to any given entity E is required to exist. Okay, so now what that means for our example is that so in this, if a movie, if we have a many to one relationship from movies to studios, and then I have a rounded rectangle like this, so then it means that if movie is pointing to a studio, then that studio entity should exist in real life. In other words, the movies, when we are materializing this relation into a table, uh, for each and every of those tuples, it should point to an valid studio in the studios table, right? So now let's take over here, right? So here it's studios and presidents, and we have the relationship runs, right? So as I said before, that whenever you have a one-to-one relationship, the way to think is that this bold arrow means that it's a many to one relationship from studios to presidents, and then if we had a bold arrow over here, it is a many to one relationship from president to studio, right? So a relationship which is many to one on both sides is actually one to one, right? So now let us see what does this curved arrow and this bold arrow over here is meaning. So now this curved arrow or towards the studio, what it means is that if a president is indeed a president, right, then that if that guy, if he's running a studio, then that studio is allowed, should exist, right? Right, he should not be running a studio which does not exist. So that is this curved arrow over here. Whereas the bold arrow, I'm you pointing a bold arrow to the president. So that means when I see this runs relationship from the studio side, I am allowed to have a studio with where the constraint that it has no president. Okay, I am allowed to have that. So that's a reasonable assumption. Okay, a studio can exist by itself without a president, because it can happen when the president gets fired or something like that. But if a president is indeed in the position of power, then he should be a president of a valid studio, otherwise it does not make sense, right? So this is the concept of referential integrity. I doubt you will ever get a complicated thing like this, in at least in this course. In real world, we never know. But this example on the left side is probably more valuable towards you. It says that if movie is pointing to a studio, then that studio must exist, right? Right. But as I said before, in practicality, when you're doing things at the schema level, when you convert this relation into a table, you automatically put the required foreign keys without even thinking twice. Okay. So probably I'll stop here, uh, right? And then we'll start a new video on some design principles of ER model.